welcome back to my system design series. You might have heard everything changes and nothing stands still. These are the words by Heraclitus are more relevant today than ever. Especially when it comes to the software. Think about it, application which you use such as Instagram, Netflix or weather forecast on your phone didn't always look or work the way they do now. They all are evolved. New features are added, old features are updated or removed. And the way this application handles and store the data has also changed. In this video, we will explore how to build a system that can adapt to these changes easily. We will break down the concepts, use simple language, and include real-time examples to understand these all concepts. Okay, so first question is why do applications and data change? The first reason is new features are added. Let's say we have an application called Netflix. When it started, it was just renting DVDs. Then it evolved to streaming the movies. Later, they added the features such as user profile, personalized recommendation, and even allowing downloads. Every time the new feature is added, changes are made to the way data is stored and processed. Second is users expect more. Okay, what do you mean by this? Imagine using a simple weather application. At first, it only tells you the temperature. But as the time goes on, user want more hourly forecast, air quality updates, or severe weather alerts. To deliver these new features, the application's data storage and functionality needs to change. Third is business needs evolve. Okay, let's talk about an e-commerce like Amazon. During the events like Diwali festival or New Year festival or Black Friday, millions of the users shop at the same time. To handle this load, Amazon might need to change its system, improving the way orders and payments are stored, processed or tracked. So, change is inevitable and the better your system can handle this many changes, the smoother the experience of users. Okay, so how do this database handle this kind of changes? There are two ways that database can handle these changes. First is relational databases, that is schema on write. Relational databases such as SQL or PostgreSQL are like a strict set of rules. Before you add the data, you need to define exactly how the data will look. For example, if you want to store the user information, you might define columns like name, email, phone, etc. If you suddenly decide to add the new feature such as profile picture, you will need to go back and change the structure of your database. This is called schema migration. It is like adding the new rule to your existing system. For example, a food delivery application such as Swiggy or Zomato, if they want to add a new feature called live tracking, the developers needs to update their database to include GPS coordinates, timestamps and delivery partners IDs. Second is schema on read or seamless. These seamless databases like MongoDB are much more flexible. They don't enforce a strict structure for data. For example, if you have the older user profiles without a profile picture field and newer ones with the profile picture field, that is okay. The database don't force all the data to look alike. So think of this way, a relational database is like wearing the uniform. Everyone must follow the same rules. Second is schema on read or schema-less database. So this schema-less database such as MongoDB are more flexible. They don't enforce a strict structure for data. For example, if you have the older users without having the profile picture and the newer ones or the newer users have the profile picture, so that is okay for this. The database don't force all the data to look the same. Think of it in this way. A relational database is like wearing the uniform. everyone must follow the same rules. A schema-less database is like dress casual. People can wear different styles and different colors. It doesn't matter. Okay, so now when you update the system, you can't do it all at once, especially for the large application. Instead of that, you do it gradually. This is called rolling update or staged roller. So these also have the two types. The first one is server side applications. Let's say you are running a service like Spotify. When you release a new feature, you don't update all the servers at once. Instead of that, you start with the few servers and check if everything works fine or not. If there are no issues, you gradually update all the servers. This method avoids the downtime and makes the system more reliable. Okay. Second is client side application. So think about the application that are running on your phone. Unlike the server side updates, here the company don't force you to update your application. For example, if WhatsApp have released a new feature but you haven't updated your application, you are still using the old version. This means the old version and the new version of the application must work together. The system must handle backward compatibility. Backward compatibility. That means newer apps can read old data. And forward compatibility. Forward compatibility. That means older apps can ignore extra fields in new data. Okay, when we work with the data in programming, it usually exists in two forms. First is in memory. This is the place where your data lives when your program is running. Think about the data stored in objects, lists, array, hash tables, or trees. These structures are optimized for your computer's CPU to access and manipulate quickly. For example, if you are building a e-commerce website such as Amazon, your product inventory might be stored in the memory as a hash table where product IDs will be work as keys and details like price and description work as values. And when you save the data to the file, send it over the network or store it in the database, it has to convert into a format that can be transferred or saved. Okay. Why? Because memory specific representations like pointers don't make sense to other systems or processes. For example, if you are sending your product details to a mobile application, the data might be encoded as a JSON string. So it will look something like this: ID 101, name, Archie, then price, maybe infinite. Here, the JSON document is a sequence of bytes that can be easily transmitted over the internet. Okay, so you might think that why do we need encoding? Think of encoding as a language translator. When you translate from in-memory data structures to a format like JSON, XML, or even binary, you are enabling systems to communicate with each other. This process is called encoding or serialization, which means converting in-memory data into sequence of bytes. Second is decoding or deserialization. This means converting sequence of bytes into in-memory data. Okay, let's take an example. Imagine that you are working on the banking application. In memory, account details are stored in objects. To send the account details securely to a server, you encode them with JSON. The server decodes the JSON back into its own objects. So, this translation ensures seamless communication between different systems. So, let's talk about the common encoding formats. There are countless encoding formats available, but let's focus on the major ones and its use cases. So, first is language specific format. Many programming languages provide their own built in tool to encode or decode the data. For example, Java has java.io.serializable. Python have Pickle. Ruby have Marshall. This format allows developers to save in-memory data with very little effort. Okay, so let's take it the example of Python. Here is the data. Here we are doing the serialization, that is encoding, and here we are doing the decoding, that is a deserialization, and this is the output. It sounds very simple, right? But there are some major drawbacks of using language specific formats. Let's explore them one by one. Okay, first is lack of cross language compatibility. Imagine your application stores data using the Python's pickle format, but you want a new microservice written in the Java to read the data. This won't work because the data is encoded in a Python specific format and Java doesn't understand that. So real world example would look like that if Amazon is using Python to encode all its product data and later needed to use Java to analyze the data, they would face the huge compatibility issue. Second is security risk. Language specific encoding often allows decoding into arbitrary object types. This creates a massive security loophole. Let's say your server accepts the encoded data from the users. A malicious user could send an encoded payload that creates dangerous objects on your server, like objects that execute arbitrary code or leak sensitive information. This is why it is important to use encoding format that prioritize security. Third is versioning challenges. Applications evolve over time. For example, you may add new fields to your objects or change their structure. Language specific format often lacks good support for handling these changes. For example, imagine your e commerce system originally encoded the product data. Later, you added the price field. Older data won't know how to handle this change. So, proper versioning strategies are crucial. But these libraries often treat it as like afterthought. Fourth is inefficiency. Some language specific formats are bloated or are slow. For example, Java serialization is infamous for its poor performance. This efficiency can be a bottleneck when working with the large data sets or high traffic systems. So, if language specific format has so many issues, then what should we use? Let's talk about some popular alternatives. First is JSON, that is JavaScript Object Notion. JSON is one of the most widely used data format. It is simple, human readable, and works well across all the languages. So it looks something like this: ID as 100, name as RG, like this. So, what are the pros of using JSON? It is easy to read and debug. Second, it is supported by all programming languages. Third, it is great for APIs and data exchange. Okay, so let's talk about the cons. First, they have large file size. Second is parsing can be very slow for large file or data sets. Okay, so that was all about JSON. Let's talk about XML, that is Extensible Markup Language. XML were widely used before JSON became popular. It is still used in some of the industries such as banking and healthcare. So this was how it was look like. Suppose this is product, it would be slash product. Product is having the ID such as 101. We will close the ID. It is having the name property as RG slash name and age as 25. So pros is it is highly flexible and it supports metadata through attributes. Okay, so let's talk about its con that it is extremely verbose. That means it have larger file sizes. Second is it is much complex in parsing compared to JSONs. Okay, so let's talk about the third format that is binary. For example, protocol buffers, Avro and Thrift. Binary formats like protocol buffers, Avro, and Thrift are designed for efficiency. Protobuf encodes the data into compact binary format, reducing size and improving performance. So, pros of using binary data are it is much smaller and faster compared to JSONs or XMLs. It is strongly typed and version for compatibility. But its cons are it is non-human readable and second is slightly harder to debug. So when you are deciding the encoding format, consider this point in the mind. First, do you need the cross language compatibility? If yes, then use JSON or Protobuf. Second, do you prioritize the performance? Then use the binary. If you need the human readable data, then JSON is the good choice. So in real world example, if you are building the API, JSON might be the best choice for simplicity and compatibility. But if you are designing the high performance database, you might use Protobuf. Let's talk about the fourth one that is CSV, that is comma separated value. CSV is very simple format used for storing tabular data. Think of it as what you see in the Excel sheets, but in a plain text. So here is an example. Name, age, skills, or Archie 25, coding. Like this, it will be storing the data. Each line represents the row and each value is separated by the commas. CSV is the lightweight and perfect for the spreadsheets or when you are exporting the data from the database. Okay, so next question in your mind would be why do we use these formats? All these three formats, that is JSON, XML, CSV, are language independent. That means it can be used with any of the programming languages. They are widely used, making them go-to choice for first data exchange. If there is a data exchange between different systems, we are using the APIs. If we want to store the configuration file, we use the JSON format. If we want to export or import data, then at that time we are using the CSV. But just because they are very popular, that doesn't mean that they are perfect. Let's talk about some common problems while using this particular formats. Let's talk about the problems with JSON. JSON can't tell the difference between the integer and the floating point number. For example, 10 or 10.5. Large number, for example, Twitter's 64-bit tweet ID lose accuracy when passed in the JavaScript. So how Twitter solves this issue? They send the tweet ID twice. One as a number and second as a string. So suppose this is the Twitter ID. First they will send it as a number and second as a string. Okay. Suppose the ID is 1 2 3 4 5 6 7 8 9 0 1 2 3 4 5 6 7 8. So first it will send it like a number and second it will send it like a string. 1 2 3 4 5 6 7 8 9 0 1 2 3 4 5 6 7 8. JSON can only store text. If you want to send a file, for example, any of the image, you have to encode it in base 64, which increases the size by 33%. This makes JSON inefficient for transferring the files. While JSON can have a schema that means rules about how the data will look like. Many tools ignores it. This means developers have to write the extra code to validate that data. Okay, so let's talk about the problems with XMLs. XML uses opening and closing brackets for everything, making it bulky. Okay. Compare this, like for example, in JSON, it is like ID S101. Okay. But in XML, it would be like ID 101 slash ID. The another point is XMLs have the features such as namespaces and schemas, which are powerful but complex. This makes harder for the beginners to pick up. Like JSON, XML don't support the binary data. Developers must use base 64, which is not efficient. Okay, so let's talk about the problems with CSV files. CSV files don't have their built-in rules about how data should look. It is up to the application to decide what each column means. For example, if the new column is added, older applications might break because they don't recognize the new format. And if a value contains the comma or a new line, it becomes tricky. Also, CSV is flat, so it can't represent the complex data, for example, JSON or XML. And please make sure you like this video, subscribe to my channel, and leave the comments if you have any kind of doubts or suggestions or you want any particular topic so that I can make the video on that. Check out the descriptions if you want the more resources supporting the information which I have explained, and see you in the next video.